Okay, so just so you know, this is take 3 of this video because of open house. So hopefully I won't get disrupted again. But if I do, we're just powering through because I got to get this done. Alright, so today what we're talking about is relations of and functions. So we got to talk about what is a function, how we know it's a function, and then we're going to talk about domain and range. So this will be Unit 2, Lesson 1, if you're writing that in your notebook, or you can just call it Lesson 2.1. Alright, so let's start by talking about what is a function. So a function is a relation in which each element of the domain is paired with exactly one element of the range. So domain, remember, is all the set of all x values, meaning if we had a coordinate grid, the domain goes from left to right, least to greatest, and that's what we write. Range is the set of all y values. So if we had a graph, the range goes that way, least to greatest. The true definition of a function says that a function cannot have repeating x values. So anytime a function repeats an x, that makes it not a function anymore. And in this course, it's important to know that because a lot of times we decide if something is or is not a function, and it tells us whether or not to move forward with whatever we're doing. Alright, so there's 4 different ways to talk about how to identify a function. So the easiest way is ordered pairs. So you know that like if I have 3, 2, 2, 1, and 5, 6, that's a function because the relationship is x and y. So we would say the domain of that function, we would call it a set of numbers, negative 3, 2, and 5. I just take the values of x and put it as the domain. For the range, I do the same thing. I take the values of y, which would be 2, 1, and 6, and I list them. I should have listed them in increasing order, but that's okay that I didn't just for today. Okay. Now we can also see it written as a table. We could say x and y. We call this a t-chart. Say we have negative 3, 2, 2, and 1. So again, the domain is the x, the range is the y. I would do domain. A squiggly line means the set of numbers. And we have a negative 3 and a 2. The range is how I'm going to do it correctly. So it should be 1, 2 because we want it least to greatest. Okay? Another way to see a function is with mapping. So say we have 2 circles like this, and within the circle, the first one's always the x. We're going to have a 3 and a 2, and let's just say we have a 4 here. Okay, with mapping, you know it's a function if each x only has one arrow coming off of it. So even though they go to the same y value, this is still a function, so we can put a check mark, because from x to y, there's only one arrow going that direction. So all 3 of those methods are things you saw in Algebra 1. So the thing that we really focus on with domain and range in this course is graphing. So say we had something that looked like this. Okay, and say it had arrows like that. Now we know that it's a function because if you go along the line, none of the x values repeat. But to list out all of the coordinates that lie on that function, it would be really daunting because there would be tons of coordinates to write. We'd have to write all of the ones that are decimals plus the whole numbers. So because of this, we're going to learn today about an interval notation, or actually an equality notation that helps us to do that. But first let's talk about the vertical line test. Okay, so the function that I just drew, let's talk about it. If it goes like this, okay, to test to see if it's an actual function, what you do is you draw a vertical line. Alright, I drew that line and only hit the function once, so that means at that point it's a function. If I draw it this way, it only hits the function once, so that makes it a function. In contrast to that, something that would not be a function, say we had a circle. Well, if I draw a vertical line, I've now hit that function at 2 different coordinates, meaning there's 2 different x values. So this is not a function. So if you're talking about a graph, the easiest way to say whether it is or is not a function would be to draw a vertical line and see if it touches the graph more than once. Alright, so let's talk about inequality notation with domain and range. So this is going to be inequality, and this is something that you probably did in Algebra 1 as well. So it should be a refresher. The ones we learn the next 2 days will be newer. Okay? So say I have a graph, and I have an open circle here, and then a line comes down, and then I have a dot here. From there, I go down, up, and I'm going to stop it. Oop, that was a terrible line. That's okay. I'm going to stop it right there at that coordinate. So remember that domain goes this way. So what you're looking for is your endpoint values. Now why did I draw a closed circle versus an open circle? So you have to remember an open circle is the greater than or less than symbol. A closed circle is greater than or equal to, less than or equal to. Now we saw that when we did our dotted lines with systems. Dotted meant that it was not included in the graph. Or solid meant it was included in the graph. So it's the same thing. Open, dotted means it's not included. Closed, line means it's included. Okay, so this is what we would do. We would first find this x value at this farthest point. So let's count. 1, 2, 3, 4, 5, 6, 7. So my domain starts at -7. Okay? Now all the x values in between, even though I put this dot, it's still included in the graph. The graph goes all the way here and then stops over here. Because this was an open circle, I'm going to use the less than sign. And x goes in the middle. Now my x, so this says -7 is less than x. So then we need another inequality to determine this endpoint over here. So let's count this endpoint over here. So we got 1, 2, 3, 4, 5, 6, 7 again. Because it's a closed circle, I'm going to use less than or equal to, and I'm going to say it's 7. So what the domain tells us is that this function goes between -7 and 7. It's an open circle at -7, and it's a closed circle at +7. Now let's do the range. The range, remember we want least to greatest, so it's going to go down, up, that's the range. You're always looking for the furthest point down. So even though there's a dot right here, my graph goes past that dot. So say the dot goes to the graph goes to here. This value is your starting range. So say 1, 2, 3, 4, 5, 6, -6. So we start at -6. Because it's a part of the line, it's going to be less than or equal to. There's no open circle there. Then we go up here. Well, now we have to think about it. So it goes 1, 2, 3, 4, 5. If I draw a line at 5 going across, the function is not included over here. But because this closed circle is over here, this closed circle trumps the open circle, meaning it overrules it. So we would say that -6 is less than or equal to y, which is then less than or equal to, what did I say, 5? 1, 2, 3, 4, 5. So what this inequality notation tells me is that the function or the picture should basically lie between -7 and 7 on the x and between -6 and 5 on the y. Alright, so inequality notation uses less than or equal to or less than. It never uses greater than. You should never write something like this, because that doesn't make any sense. Okay, so don't do this. They should always be facing with the arrow pointing to the left. Okay, let's try one more. Okay, so let's do one more inequality notation. Alright, so say we have an open circle here. I keep going to the same point. Say the graph goes this way and then stops here. So, my graph for the domain, remember domain goes from left to right. Now I have an open circle here, so that means I'm going to use the less than sign. I'm going to have an x. I have a closed circle on the other side, so I'm going to use the less than or equal to sign. And at that point, all you're doing is finding your endpoints. Now in class tomorrow, I'll talk about how you can use your hands to find the endpoints, or index cards to find the endpoints to help you kind of trap the graph so you see it a little better. But let's count this out. So it's 1, 2, 3, 4, 5, 6, -7, because I like that number evidently. This one is at 1, 2, 3, 4, 5, 6. So the domain of this function goes from -7 to 6, meaning it stops at -7 on the x, it stops at 6 on the x on the other side. So let's do the range. Now even though the range, there's points here and here, our function goes all the way to the bottom down here, and it goes all the way to the top up here. Let's just go ahead and make that this line. Okay. So you want to do your range. Range goes from top or from bottom to top. So our bottommost y value is -1, 2, 3, 4. Because it lies on the line, it's not an open circle, I'm going to say that it's less than or equal to y. Alright, my topmost point sits at 1, 2, 3, 4, 5, 6, 7, 8. Okay, again, because it lies on the line, it's going to be less than or equal to. So the domain of this function is this, the range of the function is this. That's the most important thing to know about domain and range, is that it's the endpoint values, and the signs in between come from whether it's open or a closed circle. So tomorrow in class we'll practice finding domain and range and writing it in inequality notation. We're also going to learn 2 more notations later in the week, but today we're just starting with this one because you probably have seen this before in Algebra 1. If you haven't, then that's okay, we're going to practice it tomorrow in class. So make sure you take notes. If you're a little confused, go back. I know I talked a little fast. Go back, reread what I wrote, watch the video again. Remember to take notes. And for your entrance ticket, because I told you I would put an entrance ticket in there, let's do this. If it'll come up. So our entrance ticket is going to say, entrance, not entrance. I want you to write the domain and range for a function, meaning it has to have no repeating x values, you create. So just like I did, I want you to draw your table, draw your x and y axis, come up with a picture of something that is a function, meaning that nothing repeats, no x or y repeats. So say mine, I might do a closed circle here, it goes up, it comes down, it goes up again. Okay, then I put an open circle. I want you to write, so you have to draw a function, then you have to write the domain and range for the function that you drew. Okay? In order to get 100 on this assignment, you have to at least attempt it. Write down the directions, draw a picture, find the domain and range. Remember, domain goes this way, range goes this way. And then tomorrow in class we'll discuss in our groups whether or not we think we drew a function and whether or not we have the right domain and range. So everyone should have a different picture. No one should have 2 of the same pictures. Alright, hope you have a great night.